So in this video, we are going to discuss about Schmitt trigger. So we know that the comparator which will operate in open loop mode, and this open loop mode which is having the open loop gain which is very large, right? So because of that, what will happen means false triggering, right? False triggering at the output can occur. Even due to a few 1/10th of milliwatt peak of the input or less. Even such less voltage, there is a possibility that false triggering at the output can occur. Okay, since the comparators, we have designed the comparator with we have to design the comparator with positive feedback. Okay. Therefore, the comparator has to be designed with a positive feedback. Okay. To avoid this, false triggering, false or unwanted triggering. Which is called as Schmitt trigger or regenerative comparator. Okay, regenerative means positive. Okay, regenerative comparator. So here, when the input changes as slowly as but here in the false triggering, what is false triggering means, since the input is changing very slow as compared to the output, noises also get coupled from the output back to the input. Okay, so in order to avoid that one, we are using the positive feedback, and that is called as regenerative comparator or Schmitt trigger. Okay. So in Schmitt trigger, the beta OL, okay, beta OL value is equal to 1, and therefore AVF value becomes infinite. Okay, but it is not so in the case of practical value. Okay, so let us discuss about the construction of the Schmitt trigger. So since we have employed positive feedback for the Schmitt trigger, I can draw like this, right? So this is your R1 and this is your R2. And this is your V0. Okay. So this is plus VCC and this is minus VE. Okay. So you can see I have used a positive feedback. Okay. From the output, it is connected to the plus of the op-amp. Okay. So consider current flowing through this one is I1. So here there is no current, there is 0. So here also the current value is I1. Okay. So therefore I can write V0 is equal to I1 of R1 plus So let me assume this point is nothing but VR2. Okay. So what is the value of VR2? VR2 is equal to V0 into R2 divided by R2 plus R1. Okay. Consider I'm having the input V in. Okay. So this is my V in. I'm using a triangular waveform. So this is your V. Okay, it is changing with respect to time. Okay, and this point, this is called as 0 point. Okay, this is nothing but your 0 detector. Okay, since I have used a Schmitt trigger, I can write this VR2, right? So the VR2 value is nothing but VR2 value is equal to UTP. I can write this is as UTP. That is plus V0 of R2 divided by R2 plus R1. Okay. And another I can write it as LTP, lower threshold point. Okay. Our triggering point. Okay. Lower triggering point is that is minus V0 of R2 divided by R2 plus R. Okay. Yeah. Okay, so this is your VI, and I can choose this one as my UTP value, and this point as lower triggering point. Okay. So since it is a comparator, if the plus value is greater than minus, okay, if plus value is greater than minus, you will get the V dot becomes VCC, right? It goes the maximum value of VCC, right? When plus is less than minus. Okay, this is the first case and this is the second case. If plus is less than minus, V naught is equal to minus V. Okay, the maximum value it will goes up to minus VC, minus V. Okay. So you can see this is your VI. So here the UTP represent nothing but the plus value, right? These two are the plus value. Okay, so here after this point you can see the minus value only I have given to the VA, right? You can see for minus I have given to VA, and plus is nothing but this rose color pink color line. Okay, so whenever the minus value is greater than the plus value, you will get the output as 0. Sorry, minus V1. Okay, that is a minus V0. Okay, so let me assume this this point is nothing but minus V0. Okay, so till it will reach this till it reaches the LTP value. So you can see the LTP value. So now after the LTP value, here you can see the minus values less than the plus value. If minus value is less than the plus value, okay, so here this is minus value, right? So this minus value is less than the positive value. So it will goes again it will again go to plus V0 till it will reach this this circuit converts a slowly varying input voltage into a square wave output. Okay, hence the circuit is called as a square. So let us discuss what is hysteresis. Hysteresis means it is a difference between the upper threshold point, triggering point, and lower triggering point. So the effect of hysteresis is elimination of the noise trigger. Okay. So consider the circuit, and if I have a zero crossing detector at this point, okay. This is your input waveform, and this is your zero cross detector. Okay. So whenever the input waveform is more than the zero value, you will get zero output. Okay. So at this point, you can see at this point you will have a zero value, because here the pink value is greater than this zero value. So you will get 0 till this point, right? So at this point the zero value is greater than this pink line. So till this point. Okay. So at this point you have again a lower value. So at this point you have the plus value, zero value is greater than the pink value, right? So again you will get positive value. So at this point you have again this pink value is greater than the zero value. So again it goes to 0. So you can see there are a lot of triggering which is happening, right? So this can be avoided with the help of by using a Schmitt trigger, which uses multiple triggering, right? The multiple triggering around the zero level can be avoided by using a this Schmitt trigger. Okay. So this is the input and output characteristics of the hysteresis of a Schmitt trigger, right? So this is your VA and this is your minus VA, okay, and this is your V0 value and this is your minus V0 value. Okay. So the difference between the UTP and LTP is nothing but your hysteresis. Consider the circuit at the point from so this is your LTP value and this is your UTP value. So if so the LTP value and UTP value is given to the positive, and this one is negative value, right? This is your negative value. So if here you can see at the point 1, this is at LTP, right? So at the point 1, if my what is the V0 value at point 1? At point 1, V0 is equal to V0 saturation, right? V0 saturation. So this point is called as V0 saturation. This is nothing but V0 minus V0 saturation. Okay. Because the positive value is greater than the negative value, so it goes to V0 plus V0 saturation. Okay. And you can see, and the VA value is less than this LTP values, right? So this is your VA value. So the VA value is less than the LTP value, right? So this is the first point. So second point is, what is the value at V at point 1? V naught at point 1, it is nothing but V naught saturation, right? Positive value. Okay. So the positive value is same till it will reaches the point called V, point V. Okay. So from point 1 through 2 and 3 till it will reach 2 and 3, the V naught is equal to V naught saturation, right? V naught saturation. Though the VI is greater than LTP value, right? So the though the VA value is greater than this LTP value, from point 1 to through 2 and 3, V naught value will remains at V naught saturation. Okay. So next third point. Okay. So from point from point 3 to 4. So point 3 to 4. That is this point. What is happening? VA value is equal to UTP, right? This is VA. This is the VA point. VA value is equal to UTP. So my V naught changes rapidly from V naught saturation to minus V naught saturation, right? So at this point, because the negative value is greater than the positive value, so it is going to minus V naught saturation, right? So fourth point is, that is from 3 to 4. Okay. Some from 4 to 5. Okay. So from from 4 to 5. Okay. So V naught is equal to V naught saturation. You can see, right? V naught is equal to V naught saturation. It is remain at the same minus V naught saturation. Minus V naught saturation. Though this VA is and V is greater than UTP value, right? Okay. So next fifth point. From 5 through 4 and 6. 4 and 6. So it will reach this sixth point. Okay. So the sixth point, so V naught still remains in minus V naught saturation, right? As VA is reduced below UTP, right? Until it reaches VA is equal to LTP. Okay. So when LTP is reached, okay, when VA is equal to LTP, okay, V naught switches from minus V naught saturation to plus V naught saturation, right? And it will reach the point called 2, right? That is from point 6 to 2. Okay. So last point is from point 2 to 1. V naught is equal to plus V naught saturation, right? As VA reduced below Celtic. Okay. So next part we will go for the design of Schmitt trigger. So here I have used two resistance, right? One is R2 and R1. The current flowing through this resistance is I1. So I can write V naught is equal to I1 R1 plus VR2, right? So what is V naught? V naught minus R2 by I is equal to R1. So this is for from this one I can identify the value of R1. And what is VR2? VR2 is nothing but UTP, right? That is nothing but I1 into R2. So from that one, you can determine the R2 value. So R2 is equal to UTP by I1. So they have given the triggering value, that is plus or minus 2. Okay. So for UTP it is 2, for LTP it is minus 2. And I1 value must be greater than the IB max value, that is for I741 op amp it is 50 microampere. So if we substitute R2 value is 40k kilo ohm, and if I substitute in this equation I will get R1 is equal to 180 kilo ohm. Yeah. So you can design this schematic trigger also by using a non-inverting schematic trigger circuit. So next we are going to see the simulation of the schematic trigger using multiSIM. So for that, go to the place component. In that you type 741 and you select the op amp. Next you go to the resistor, and I require nearly 3 resistance. So in just spacing it, then I require a supply, DC supply. So for that one, we go to place component. In that you select VCC and V. So after selecting this one, we will select down. So I'm just spacing 2 downs. And then and post on this one, then I am going to select the oscilloscope. Okay, so you see here I am placing the oscilloscope, then I require a function generator. Okay, so frequency function generator. So this is a function generator. Next I'm going to get the connections. Okay, so the output I'm going to give it to the, you can give it to A or B, okay, whatever you want. Then from the plus side of this connecting and the 1K resistance R2 resistance. Okay, then so you know that the schematic trigger is nothing but a positive feedback, right? This negative, the inverting terminal, I connected the other end of the resistor to the function generator. Next time I'm connecting the positive supply to the 7 volt and negative supply to the 7th pin, and negative supply to the 4th pin. So the connection is done. So after that, don't connect this negative pin to ground. Next, I'm going to connect the feedback. So feedback one to the sixth terminal and another one to the third. So I'm just changing the output to B terminal. Okay. So after that, I can change the value of the resistance. So once if changing this one, I can go further. After changing the value of the resistance and the supply voltage, they can say check the value of the function generator. And the input terminal is connected to the input of the function generator is given to the output of the DSO at the A terminal. DSO at the A terminal. So here I require a ground, so I'm just connecting. So here you should not connect to this point. I have to connect it to the negative. Yep. So once if you save and run the value, you get the out. So you can see I have obtained a sine and square wave. Okay, I'm just changing the scale of A, and if I make the channel B as 0, I'll get only the channel A output. If I make the channel 0 output as 0, I get the channel B output. Okay, so the channel A is sine wave and the channel B is a square wave.